All right. Hi, everyone. Let's go through the rest of Docker end to end. The thing that we weren't able to cover in the live videos included this step number 14 and the very last step, which is step number 22 called Docker Compose. We'll cover both of these in this video. A prerequisite for this video is the live videos from this week. So please go through 15.1 and 15.2 before proceeding to this video. Let's get right into it. Maybe even before slide 14, let's do slide 13. This is something that we did not cover very well during our live class. So let's understand some more commands in Docker, specifically docker kill and docker exec. The first command is docker kill, which, as the name suggests, is used for killing something. What are we killing? There are only two things that we have really learned, right? It's either images or containers. So the docker kill command is for killing containers. So if you run docker ps, you see I have two containers running right now, a Mongo app container and a Mongo container. If I want to kill the first one, I run docker kill container ID and that will stop the first container. If I now run docker ps, you see I have a single container running. If I kill this one as well, you will see I have no containers running anymore. That is what docker kill lets you do. This is different from docker RMI, which lets you remove images. So if I run docker images, and let's say I don't require the Mongo image anymore, I will never recreate a MongoDB container for a long time, then I can get rid of this and reclaim 721 megabytes on my machine by running docker RMI Mongo. And it says Mongo is still being referenced by this container. So you can force it, considering you already know that you don't really need a container currently running the Mongo image. And it says deleted this specific Mongo image. If I run docker images again, you'll see the Mongo image is no longer here. In fact, if I run docker run Mongo, you will see it says unable to find image locally, and it would pull the image from Docker Hub. It does not have it locally anymore. That is what docker kill and docker RMI let you do. The last one is docker exec, where exec stands for execute. Let's say I start a simple container. Let's say it's a Mongo container. Docker run -d Mongo. If you want, you can also add a port mapping. Does not matter for this example. If I start this Mongo container, as you can see, it says unable to find image because I had just deleted this image a while back. It's pulling the image and then downloaded new image and then is most probably running it. It's running it in detached mode, which is why it detached out of the terminal. But if I run docker ps, you will see a Mongo image is running on my machine. How can I run some commands inside this container? Let's say I want to explore what the Mongo container looks like. In the end, what is this container? This container is, if this is my Mac machine, this container is a small mini machine inside it, right? How can I go into this container? How can I see what the file system looks like? How can I ls? How can I delete something? How can I do whatever I want inside this container? And the answer is by running docker exec. Exec states I want to execute a command inside this container. So if I run docker exec container ID and a command, I think this is right, could be wrong, but let's see. Yeah, this is right. Docker exec inside this container ls, and you will see it shows me all the contents in the working directory of this MongoDB container. Let's try that one more time. Docker ps, I have one MongoDB container running. Docker exec container ID, let's say pwd, which shows you the current working directory, which it says here is /. So this way I can run a single command inside the container. But what if I want a shell like this inside the container? What if I want to get bash access inside the container and run multiple commands inside? In this case, you should run docker exec dash IT, which means run it interactively so that it does not exit out after the command runs. The container ID followed by /bin/bash. This basically means you want to create a bash session on this container ID. Now, if I run ls, I can go into a folder. I can look at the other folder. I can keep exploring this, Mongo container. I'm right now inside this container and running all of these commands inside. If I delete a folder, let's say, it gets deleted from this specific container. As you can see, it says resource is busy, or you cannot remove it. But let's say, what can I do? There might be some file I can remove here. cd bin rmpr. There you go. I ran rmpr, it deleted it, and now it cannot find it. But where am I deleting these files? I'm deleting it inside the container. My Mac machine is untouched. I'm not running any command here. I'm running a bunch of commands inside. If I type exit, I exit out of the container, and now I'm in my Mac again, and I can run ls or whatever I want. So what's the command? It's docker exec-it container ID /bin/bash. This is the most common use case of exec, where you'll go inside a container and try to see what's up. If you want to, debug a container, let's say, see if your code is inside. This is the only place I've, used exec in Docker. But as you saw, you can also run commands without running it in interactive mode. And you don't, need it only to run it interactive mode. You can run one-off commands as well. Cool. That is what Docker exec lets you do. Now, let's move on to pushing to Docker Hub. All right. Next up, let's understand how can you push your images to Docker Hub. What do I mean by this? I basically mean if I go to Docker Hub Mongo, you can see this Mongo image that probably someone from the MongoDB team created. This is an official image that they have pushed. And you also saw how you could pull this image on your machine by doing something like docker run Mongo, or docker pull Mongo will actually pull it. But even if you don't pull it and you run docker run Mongo, if you don't have it on your machine, it comes by default. It'll show you a log that says, don't have it, I'm pulling it, and it actually runs it. This is how you get the Mongo image. But wouldn't it be nice if you could create your own image and let other people pull it? Very similar to how you push your code to GitHub or you push your library to NPM. You can push your images to Docker Hub so that other people can pull and run those images. What is the benefit of doing this compared to pushing your source code to, let's say, GitHub? This source code, when people pull, they have to do 10 different things to start the project. When they pull an image, they have to do nothing. They have to just run docker run and the name of your image, and everything works. So that's the benefit of pushing your image to Docker Hub. How can you do it? Step number 1 is simply signing up on Docker Hub. This isn't the only registry on which you can push images. AWS has its own registry. GCP has its own registry. This is just the popular one, or the one that I'd probably use right now because it's maintained by Docker. But just like GitHub, GitLab, Bitbucket are many places where you can push your code, Docker Hub, AWS has its own, GCP has its own, are various registries where you can push your images. As you can see, I have a lot of images already. If you have just signed up, you won't have any image over here. So you can create a repository. This repository is very similar to how you create a repository on GitHub. Give it a name, but notice it's part of a namespace. This namespace will become important eventually. This namespace is my username and the repository name, let's say week 15 class. And let's make it public. I think you can create a private one on the free Docker account. And yeah, if you want more, then you'll have to pay. That's how they make money. But yeah, let's keep it public for now. And as you can see, it says it has created a repository for me, and it shows me the command of how I can push to this specific repository. There are a few things here in this command, so let's try to break down this command a little bit better. It says, bro, whenever you want to push, just type docker push and this very big name. Notice it has 100x devs first, / and then with week 15 class. So your image is namespaced. If you do push it like this, and we'll come to what tag name is eventually, but if you push it like this, whoever is pulling it or whoever is running it needs to run this. It needs to be prefixed by 100x devs. This is to make sure you don't pollute the main namespace of Docker, and you are not able to create official images like Mongo. You will always have the 100x devs or whatever your username is prefix, and inside that prefix you can put whatever you want, but you cannot push to the root prefix, I guess. If you want to do this, you have to mail the Docker team, I think, or you have to have a very big paid account. I don't know, one of the two things. Most users, free users, even paid users, cannot just take the global namespace. They need to have their username prefixed along with the custom image name that you might have. The second thing you'll notice here is something called the tag name. If you remember, let me open one project from, I don't know, week 15, which has a Docker file. So this is a simple, this one doesn't have a Docker file. Week, it does, but why does it have a Wrangler term? Let me open a different one. 15 live 2.2. Let's open this. All right, I opened the project up in Visual Studio Code. If you look at the project, it's the same project we did in the last video. A simple Express application which exposes two endpoints. One to save some data of a user, one to get all the users that exist in a database, and a simple db.ts file that basically exports the Mongoose model based on this schema. The important thing here is the Docker file, which if you look at it, it's a very simple Docker file for a Node.js project. Base image node version 20, working directory /app, copy over the package files, run npm install, copy over the rest of the files, run npm run build, expose the 3000 port, and node dist index.js is the final command that runs when the container starts. If you don't understand the structure, you should probably go through the last two videos. The question comes, how can I create an image out of this so that I can push it over to this Docker Hub repository that I had created? I need to build the image somehow and push it over here. It already gives me a hint. It says Docker push. This should be your image name, and it says :tag name. This tag name is something we haven't really seen much. So let's try to first build the project. Docker build -t dot. We have to give the tag name over here. Until now we were giving names like Mongo_app or whatever name you want to give. But since I have to push this repository, this image eventually here, the name I would give to this specific image would be this 100x devs /week 15 class. So when you're creating your image, make sure you're tagging it with, not exactly tagging it with, you're giving it this name. -t space this thing actually means you're giving the image this name. Tag is something else we'll come to very soon. When I build this and do a Docker images, you will notice, we'll make this full screen here. You will notice I have a new 100x devs /week 15 class image created. This specific image, now I can push over here. If I simply run Docker, maybe even before pushing it, if you want to try to run it, you can run, Docker run 100x devs /week -15 class. And it shows something is running on port 3000. I did not add a port mapping, which is why I don't see anything on localhost colon 3000. But if I do add a port mapping, I'll see it here very soon. As always, my image has dangled. Sorry, my container is running. So let me quickly do a Docker. Let me show you what I'm doing. I'm basically trying to exit the image out. So I created another terminal. And here in this other terminal, I'm going to do a Docker kill. Let me just stop everything. Now, if I go back to the original terminal, you'll see this has exited. And now I know that the application is able to run. What I want is for everyone to be able to run this application. And so I'm going to push this over here. It's as simple as doing a Docker push and the name of the image. I already have this image. I already have the 100x devs /week 15 class image here. And as you can see, it says repository, this tag latest. We'll come to what this tag is very soon. But for now, I can simply do docker push and name of the repository. And this will work if you have logged in Docker. I repeat, you first have to make sure you log in the Docker CLI. So run docker login and put your credentials over here. In my case, it said login succeeded because I've already logged in. But if you haven't, put your username and password here. If you logged in via Google, Facebook, you used some single sign-on, then you'll have to go here into my profile and create a new, what's called, let's see, not my profile, my account. You'll have to go to my account, click on security and create a new access token that has read, write, delete access. Maybe just write access is also fine, but you need to generate this and then you can use that as your password. If you used single sign-on, what is single sign-on? Login with Google, login with Facebook. Because if you did a login with Google, you have no password. So create an access token if need be. If you have a password, just put your password over here. And then your Docker CLI has access to your account and you can run the docker push command. If I now run the docker push command, you will see it says pushing this thing over here. And now if I refresh the 100x dev / week 15 class and go to tags over here, you can see it says tag latest was just pushed. Basically one image was pushed right now. I don't know if there will be future images, but this one image is over here. It is tagged with latest. Harkirat, you did not tag it with latest. You tagged it with 100x devs / week 15 class. No. This is the repository name. When you are doing a Docker build, this is the repository name. The tag that gets attached, if you don't give it anything special, then the tag that gets attached is latest. As you can see, it says this is the repository name and the tag is latest. Or if during build, I did something like this, okay, this is the repository name, colon, tag is, let's say, version 1, v1 or v1-dev. Then the image that is being created will have a, as you can see, I have the 100x devs week 15 class with v1 dev tag. I also have it with the latest tag. So I have two different variants, I have tagged the images differently. This is the latest image. This is v1 dev image. Let's say I make some changes, then I can create a v2 dev image. Why is this useful? Because you have on the same repository, you have multiple versions of your image. This will happen, right? As your application grows, you add more code, you'll be pushing more and more things to Docker Hub, and you want all of those versions to be tagged. For example, if I go to Mongo Docker Hub, you will see it has latest tag, 5th version tag, 5.0.25, 5 focal, 5.0, 5 focal, 5, 4.4, 4.3, so on and so forth. It has multiple versions of MongoDB, right? It keeps on getting better and better. And every time they reach a certain version number, let's say, they push the new tag to Mongo. Similarly for us, as our application grows, we can tag our application with, a lot of times this is your commit ID. If let's say you're pushing your code to GitHub, and then every time a new code change is made, you might just push each one of these code changes to Docker Hub. And a lot of times this ID that you see here is what's used as the tag, so that every version, every commit is tagged with this ID. So it depends on, how you want to push your code, how often you want to push your code. You might be like Mongo and say, okay, I will only push major versions. Okay, 5 I will push, and then 4 I will push, then 3 I will push, only certain versions I will push. Or you can be like, bro, we will push on every commit to GitHub. Depends on how your CI/CD pipeline is how you deploy, how often you deploy to Docker Hub. The thing to know is okay, what exactly is a tag? And a tag is just a way to tag an image. Okay, bhai, this is the repository. We're eventually pushing it here, but it's tagged with latest. It's tagged with v1 dev. It's tagged with something else. And when you're pushing, then you can also do :v1 -dev. So if I now refresh this, you will see it has a latest version and it has a v1 dev version. Can you now guess what this 20 means? It basically means the tag, right? If you go to the official node image, if I go to node Docker Hub, when I'm saying from node 20, it is pulling this 20 tag from here. If I filter tags and search for 20, there's a bunch of them, but you get the idea. The image that is being pulled is this 20th version wherever it exists. And if I pull the 20-alpine version, it'll pull the alpine tag from here. So it gives your end user the option to select a version of your application in this base image. And when you're running it also, you can run docker run mongo, which will get the latest tag, or you can run, let's see. You can run something like docker run mongo : let's say 4.4.29, this version right here. I might just want to run an older version. And as you can see, it says unable to find this image locally. Even though I have the latest image of Mongo, I have this one. I did not have this 4.4.29. So it's now fetching it from there. I'm going to cancel it. I don't want more MongoDB images on my machine, but you get the idea. This is how tagging works. And as I said, if you have real CI/CD, which stands for continuous integration and continuous deployment, you will have on every commit, I repeat, on every commit, and this might sound very counterintuitive for Kirat, every commit you're pushing an image. Yeah, you also have like expiries, so you don't have to worry about, oh, this will take so much space. But on every commit, you push to Docker Hub with this thing as the tag. This is like standard practice you might see. Whenever you are, let's say, sending your code base with the image created to Docker Hub and then eventually pulling it from Docker Hub in your Kubernetes cluster. We'll do all of this eventually. But basically, this is like a common pattern in like a lot of big companies. On every commit of this is your GitHub, anytime there is a new commit here, it'll spawn an Ubuntu container, let's say, which will create an image and push that image over to, let's say, Docker Hub. And then your Kubernetes cluster that's, let's say, running in, AWS, which has a bunch of small machines, will be pulling the latest tag from here, or pulling, whatever the commit version might mean, whatever the latest tag you might have pushed over here. So this is like something we'll see eventually, GitHub. And that's the benefit of using tags. The other benefit, as you know, is, for a repository like Mongo, these tags let the end user select what version of Mongo you want to use. So they're like two different use cases, right? One is if you have a repository like Mongo that everyone's using, then you will tag it with 5, whatever version of Mongo is running over there. If you have your own code base that you want to, deploy using this architecture, then you usually tag it with the commit ID, and also every time you push, you tag it with latest as well. You can have multiple tags on an image, and then whenever an image is pushed, the latest tag gets pushed here as well. If you don't understand this, it's fine. We'll eventually get to it. That is how you push an image. Now that you've pushed an image, I pushed twice over here 200xdev/week15 class. Now, even you who doesn't have this image right now, can go to your terminal and run docker run this thing. Maybe add the port mapping -p3000:3000. So even if you run this on your machine, it will fetch this image just like it fetches Mongo and run my complete Node.js application in your machine in a single click. So you don't usually do this. You write Node.js code and then you share it with your friend. usually if you have a Node.js image, you're deploying it to a Kubernetes cluster, you're deploying it to your AWS machine. But just for kicks right now, as you can see, you can, if we were in a live class, since I have pushed it here, all of you would have been able to run this specific image locally. Not the last concept in Docker. I think there'll be a few videos after this, but the last concept for this video is Docker Compose. This is important for number one, when you're creating your own project, you should use Docker Compose. Number two, when you're setting up a bunch of projects, the maintainers of those projects have used Docker Compose. So you need to understand how it works. In fact, if you go to the CMS code base, you will see there is a, if I type this correctly, Docker Compose file at the top, the root folder. There is also a Docker file. Docker file should be mildly familiar by now. Of course, it does some, Next.js specific stuff, but fairly straightforward, right? Node image, base directory, copy things, npm install, copy the rest, expose the port. But there's another file called the docker-compose file. Let's try to explore it a little bit, and then we'll eventually see what it does. But if you look at it, number one, it is a YAML file, WML. What is a YAML file, Kirat? It's basically very similar to JSON. It has a key, for example, version, and a value which is a string. And then services is a key, the value of which is a very big object, just like JSON, right? If I put this here on the left, or maybe the right, if I put this on the right and try to write some JSON here on the left, I can write something like this: version 3.5, services, app, build, dot, so on and so forth. Like this YAML and this JSON are both a bunch of key value pairs. Now the value can be a string, the value can be an object, so on and so forth. The idea is that they let you describe data in the form of key value pairs. When you're creating a Docker Compose file, you have to create it as a YAML. Why not JSON, Harkirat? Just the people who created Docker Compose, or generally in Docker, in DevOps usually, YAML is the preferred format for key value pairs. That's the format of this Docker Compose file. It's very different from the Docker file, right? Docker file is a simple textual file top to bottom. This has indentations based on, which level of key value pair you're at. Services is an object, which is why it's inundated to the right. And then app is an object, which is why it's inundated to the right. And then build is simply a string, container name is a string, so on and so forth. That's how this YAML file has been created. We'll try to understand each one of these things, but I hope you understand how a YAML file is generated. If not, I'm sure you can find a document, a video that shares, what are YAML files. What's the high level? It's a bunch of key value pairs, very similar to JSON. Every YAML file you can convert to a JSON file as well. The question is, what is the format of this YAML file? What is services? What is app? What is version? And why do you need a Docker Compose file? What problem does it solve? Let's try to understand that next. A Docker Compose is a tool designed to help you define and run multi-container Docker applications. Why do you need Docker Compose? To run multi-container Docker applications. Compose, the name itself says you're composing multiple containers. If you have a full stack application, like we did in the last video, and even, in this specific video, there was a Node.js container that we would start. There was also a MongoDB container that we would start. In fact, we would attach the MongoDB container to a volume and we would connect the MongoDB container and the Node.js image via a network. This was the standard flow that we had followed to create a multi-container app. Our application, if you want to run it locally, you need to start Mongo, you need to start Node.js, you need to have a network, you need to have a volume. Only then does our full stack application start locally. In the future, we might have more services. Let's say there's a small Golang microprocess that does something. Let's say there is a small Kafka container that you need to start. So on and so forth. You could have multiple containers all talking to each other. You might need multiple networks. You might need multiple volumes. How would you write all of this in a single file? Wouldn't it be nice that rather than running Docker run Node.js first, and then Docker run MongoDB, and then Docker create network, and then Docker create volume, and then another Docker command, what if you could describe all of this in a single file? So you have to run a single command to start all of them. That is what Docker Compose lets you do. Before we go to the file, let's look at how would you, seems like this is not updated. Let me refresh. There you go. How would you do something like this in the pre-Docker Compose days? Let's say Docker Compose does not exist. How would you create a simple MongoDB plus Node.js application? Let's not complicate it too much. But a simple Node.js application which has MongoDB. How would you start everything? You would first create a network. Let me do that. Docker network create and name it whatever you want. I'm going to name it Harkirat_network. After the network is created, you would create a volume. After the network is created, I will create this blue volume over here. I'm going to call it Harkirat_volume. Then I will start a Mongo container, which will be this specific container right here. I need to mount it to the volume. I also need to connect it to the network. So if you look at the final command, it looks something like this. Oh, let me just type it out. Docker run -d-v Harkirat_, what was the volume name? Harkirat_volume. So Docker run -d-v Harkirat_volume --name. Let me call it Harkirat_mongo, and then --network. It was Harkirat_network. Is there anything else? No. Mongo. Harkirat, where is the port mapping? If you remember, I told you in the last class, if containers are talking to each other, then you don't need to expose this on the host machine. Containers can directly talk to each other without any port mapping. Port mapping is for this guy to expose it to the host machine. We don't want it exposed on the host machine. Let's say we simply want this container to be able to talk to this guy, which is why single network is used. Command one more time. Docker run in detached mode on this volume with this name on this network, the Mongo image. Image has been started. What is the next command I need to run? I need to start this Node.js image. Before that, you need to build an image as well. So we can again go through our pet example of a simple Node.js application which has MongoDB data in db.ts and a bunch of routes which I deleted a while back. Let me get them back in this index.ts file. The same MongoDB image we've been, the same Node.js code base we've been working with for a while. First, you need to build the image. So Docker build -t Harkirat_image dot. I'm prefixing everything for Harkirat with Harkirat for this specific example. Now that this image has been created, I'm going to run this final Node.js container. So Docker run Harkirat_image, but what do I need to attach it to? I need to attach this guy to this network. So --network Harkirat_network, and this needs a port mapping because I want the end users to be able to talk to this Node.js application from port 3000. I want to allow the end users to be able to talk to it on port 3000, which is why I'm going to also add a port mapping. Is that it? I think that's it. Do we need anything else? Probably not. I will not start it in detached mode. I'm just starting it, natively on the browser. Sorry, in the terminal. When I run this, I don't see a log here that says connected to MongoDB, which tells me there's some bug somewhere. But let's see if I'm able to open the backend application. Seems like it doesn't connect to MongoDB. We can quickly debug why. Oh, I know why. The reason is the MongoDB URL that I have here in Visual Studio Code is localhost. I need to replace it with the image name, the name of the, not the image name, the name of the container that's running MongoDB, which in my case, I think was Harkirat_Mongo. So if I replace this with Harkirat_Mongo, if I rebuild the image and now try to run it again, let me close the existing container. And now let me try to restart it. This time it should work with the database connected. So this is how you would start a multi-container application without Docker Compose. This is great. There's no downside to this. The only problem is if you're giving these instructions to a new developer, let's say, they have to do 10 different things to, start the application. They need to understand, the MongoDB database. They need to run a bunch of commands. What if they could run a single command that would bootstrap everything, that would start all the containers, create the network, create the volume, attach this to this volume, attach this to this network, attach this to this network? Wouldn't it be nice if, and even, export these port mappings? Wouldn't it be nice if you can write a single file where you can describe all of this? And the answer is yes, it would be nice. And that's exactly what Docker Compose lets you do. Docker Compose lets you, with Compose, you can use a YAML file to configure your application's services, networks, and volumes. Services, as in the containers, networks, this thing right here, and volumes, this thing right here. You can configure all of that with a single YAML file. Then, with a single command, you can create and start these services from your configuration. So in the end, for an application like this, where you have a MongoDB image and a backend image, the Docker Compose file would look something like this. Again, it's a YAML file. First, you should understand YAML, and only if you understand key value pairs and YAML, should you aim to explore this file. The YAML says, bro, we are using version 3.8 of Docker Compose. This is just as Docker Compose as an application grows, this version keeps on going up and up. And I have two services. What are these services? These are the containers that you're starting. How many containers do we need? Let me open these two side by side. We need container number 1 to start Node.js, container number 2 to start MongoDB, which is why you will see it says services. I have two services, a MongoDB service and a backend service. If this syntax seems weird, services : similar to creating an array in JSON, where this is the first value of the array and this is the second value of the array. This seems weird. Try a few conversions from YAML files to JSON files in ChatGPT, JSON files to YAML files in ChatGPT, and basically try to see if it try to see how they're both the same thing. It's just a different way to write key value pairs. Let's look at the two services that we're starting. What are services? These containers. The first one is called MongoDB. This one right here. The second one is called, I've called it backend 2.2. You can call it backend. There was a reason I added it, took the screenshot at the wrong time. So you can name it whatever you want. And then for MongoDB, where does the image come from? What is the image called? If I open the terminal, what do I start Docker run Mongo with? It's this image name right here. And I don't want a specific tag, which is why I've written Mongo. Similarly, to describe the image that you need, you put it in the image tag. What is the image for the second one? I've called it backend 2.2 because that's how I will compile my final image. We'll see this very soon. But if your compiled image, when you ran docker build locally, whatever name you gave to your image is the name that you need to put over here. Let me quickly do that. Let me go to projects and week 15 live 2.2, which is the same MongoDB project that we had. And let me build this using docker build -t dot and name it backend 22. Sorry, backend 22 dot. And now I have an image that's called backend 22 as soon as this finishes. Takes a long time because I had removed MongoDB. So it's bringing MongoDB locally to my machine. Sorry, not MongoDB, Node. Yeah, there you go. We'll wait for some time for this image to build. And there we go. We have a backend 22 image built. So rather than running docker run -p 3000 colon 3000 backend 22, I'm doing this. I'm saying backend 22, please use image this thing. This is the name of my container, the thing that I would give using the name tag. If you remember that we were giving names to these containers so they can talk to each other. That is what this name is. Depends on MongoDB. This one's slightly important. Okay, bhai, this image depends on this image, so that only when this image actually starts and finishes starting, should you start the backend 22 container. Else what will happen? This guy will start when the MongoDB image isn't ready, which is why this depends on tag becomes important as you have a bigger application as well. If you have, a service which depends on multiple things, let's say this is dependent on a Kafka instance as well, then you would have two values over here. This is an array. This depends on MongoDB and then another thing. And if you have other services that this depends on, you would put their name over here. Lastly, port mappings. We only have one right now. If we had multiple, again, this is an array. You can add multiple -3001, 3001, -3002, 3002 below it. As long as the indentation is right, these dashes represent various values of an array. And lastly, an environment variable, which basically overrides Mongo_URL to this thing right here. Notice this MongoDB is the same as the container name over here, because that's how containers communicate, right? If they're connected via a network, then they talk to each other using the container name. And the container name for this guy is MongoDB. You might ask, Harkirat, where did you connect them using a network? Which is a great question. I have not written network over here anywhere. If you go to MongoDB, I've written image, the name of the container, the port mapping, and volumes. I have written कि भाई a MongoDB data volumes needs to point to /data/db over here. Just how we used to do. Let's see. We used to do this docker run --volumes MongoDB_volume Mongo. Just how we used to put volumes here as an argument in this command. In a Docker Compose file, you put it here. All the volumes that you want mapped, for example, MongoDB volume :/data/db, you can put them over here as an array of volumes. And this MongoDB data, this volume name, you can put at the end so that Docker Compose also runs the command docker volume create MongoDB_data. So this thing that you see at the end creates the volume. Where did it go? This thing that you see at the end actually creates the volume. And this tag that you see over here actually attaches the volume to MongoDB. So this might seem a little confusing. So let's try to write this ourselves in our project. So let me open the week 15.2 live. This looks like the right one. And let me delete everything. Let me start to write everything from the top. I, of course, don't remember the syntax, so I will copy paste, but let's try to go line by line. Number 1, version. The version of Docker Compose we want to use. If in the future 3.9 comes, 4.0 comes, we will write those versions, and our YAML will also change based on whatever specification that version of Docker Compose has. Services. What all containers do I want? I want a MongoDB container, which runs the Mongo image. And I'm going to name this specific container MongoDB. And the port mapping it needs to have is 27017 needs to point to 27017. If I need more, I can add more over here. So on and so forth. And then finally, volumes, MongoDB underscore data points to /data/db. This part is the same as me doing this. Docker run --name MongoDB -p 27017 -27017 MongoDB underscore data /data/db Mongo. Rather than running this single command, what am I doing? I'm saying I'm going to write this specification in a file so that eventually Docker Compose understands and converts this into this command and runs it. That way I can describe multiple Docker run commands in the same file. That's the benefit of using Docker Compose. Now that I've written the first service, which again is a key value pair, it's an object. Services is similar to an object, which has, MongoDB as the first key, and then whatever backend application as the second key. So again, if you want to convert this YAML into a JSON file, you should try it, put it in ChatGPT, and it'll give you, this converted to JSON. Both do the same thing. Both are like ways to represent key value pairs. Second thing we need is backend. We can name it whatever you want. Image that it will use is backend. What was the name of the image that we created? Docker build backend 22. Whatever is the name of your image when you're creating it for your own application is what you need to put here. Container name, this is not needed here, but let's just name it backend application. Ports, this one needs to have a 3000:3000. Notice ports isn't a string, which is why, here image is a string, container name is a string. Ports isn't a string, it is an array, which is why it's represented like this. That's how you write arrays in YAML. This doesn't need a volume. Does it need anything else? It does. You can put environment variables here. Probably a good idea to do that, because if you go back to the code base and you go to the Mongo, go to the code base here. And if you open the source/db.ts file, you will notice we get Mongo URL from process.env.mongo URL or this default URL. So if a Mongo URL is injected by Docker, that Mongo URL is what will be used. And otherwise there is this default URL, which ideally should be, localhost. So why not inject this Mongo URL such that it represents what? Mongo : the name of this container, MongoDB : 27017. Because if you remember, whenever two containers are communicating with each other, whenever two containers need to talk to each other through a bridge network, they are able to find each other by the name of that container. If you remember from the last class, I mentioned that this guy talks to this guy, because whatever is the name of this guy, if I write ping MongoDB or whatever the name of this container is, this ping will respond to, the IP of this other container. And that's how these two containers talk to each other. The MongoDB name resolves to this IP, similar to how localhost resolves to some IP or google.com resolves to some IP. So what am I doing? I'm saying, bro, I'm going to inject this MongoDB URL. Of course, this looks incorrect, or maybe not. MongoDB : // this looks right. Such that this container name and this name is same. If I rename this to MongoDB 123.123, then of course this needs to change as well. This name represents this -- name argument over here. All right. And lastly, two things that are left is, Harkirat, where did you create the volume and where did you create the network? These two things you haven't done. And the answer is, whenever you have multiple services in the same Docker Compose, they are by default attached by a network. Docker Compose creates a network for them and says, bro, you are all going to be in the same network. So whenever it starts them in the same network, and you can already reference each other by your names. Volumes though, we've accessed a volume over here, MongoDB underscore data. We haven't told Docker Compose to create it. We haven't told Docker Compose to run Docker volume create name of a volume. And the way you can do that, the way you can tell Docker Compose to create a volume is by doing this volumes, which is another top level key. Not top level, maybe it is top level. Yes. Just like services is a top level key, the second top level key is volumes, which you just have to give the name of the volume, which in our case is, what is our volume named? MongoDB underscore data colon nothing. You don't have to give it a value. Similar to, doing in JSON, doing ASD colon undefined, let's say. So this is the key that you've defined. It doesn't need to have a value. And that is how Docker Compose understands that you want to create one volume. If you want to create another volume, you can do that here, MongoDB underscore data 2, so on and so forth. We're not referencing the second volume anywhere, but if I do reference it somewhere, let's say I add a volume here, then, I can reference this thing to and map it to whatever folder inside my backend container. But for now, this is our volume. If this seems weird, let's convert this into JSON. Let's Google YAML to JSON converter and see if we understand JSON a little bit better. There you go. If I convert this YAML to JSON, this is what it looks like. We create an empty JSON file here and open it up. Version 3.8 services. The first key is Mongo, which has image, container name, ports, which is an array, volumes, which is an array. And then backend is the second service, which has image, container name, ports, which is an array, and environment variables, which is an array of objects, which has key and value. Lastly, volumes, MongoDB is null. You just need the name of the volume that needs to be created. You don't need a value, which is why, it has null over here. And when you went to the Docker Compose also, it only had the key, did not have a volume. That is how you write this Docker Compose for a project which has two services. How to start this project is a different question, but I hope at least understanding how you compose a Docker Compose file is clear. If in the future we have Kafka, let's say, we can add another service here called Kafka. Image will be the official Kafka image. And then, it will also require a port mapping on whatever port Kafka is exposed on. And it's a good idea to attach it to a volume as well, because Kafka also has some persistent data it stores from time to time. But our application is pretty simple, MongoDB and backend. This is how you started. Question is, how do you start all of these containers? How do you make sure all of these containers, the volume, the backend, the MongoDB, and the network, all of them start? And the answer is, as long as you're in the folder in which the Docker Compose file is present, Docker Compose up is the command you need to run. Docker-compose up, which means start all the services mentioned in the Docker Compose file. Let's see what happens here. It's taking a long time. It says must be a string. Oh. Environment. Let's try that one more time. Services dot backend dot environment dot 0 must be a string. Is the syntax of this thing incorrect? Oh, environment must be a string. So it's not an array. Let's see what that does. It did start it. I already have a container named MongoDB, and we'll also see why this was not an array very soon. But before that, let's see, there's a name conflict. I already have a container named MongoDB. So let me name this to MongoDB 123.123, and let me change the container name here to MongoDB 123.123. Let me try that one more time. And now if you look at it, it says container created, attaching to backend application MongoDB. This is attaching it to the network, I'm assuming. And if you look at the logs, it says MongoDB, it was not able to connect to, which basically means this URL is probably incorrect. I had a feeling it was incorrect. Let's see. Mongo colon slash slash. Okay, what's the URL here? MongoDB colon slash slash. There you go. Let's try that one more time. And now if you see, it says MongoDB connected. If I go to localhost colon 3000, I have my backend application running. So now I have two containers running, a network that is connecting both of them, and a volume that is attached to this MongoDB 123123 container. If I try to explore all of this, if I do a docker ps, it shows me two containers are running. If I do a docker volumes ls or ps volume ls, you will see I have, what was our volume called? MongoDB underscore data. The keys volume is thing. There you go. Week 15 live 22 underscore MongoDB underscore data. I have this volume that is created. It is prefixed by the name of the folder I was in. This is the volume that is being used. And what is the networks that we have? We have a week 15 live 22 default bridge network that was created. Again, this you did not have to mention in the Docker Compose file. It automatically creates a network and attaches all the services. So this network was created automatically. The image I had to write over here. If I had another image here, underscore data 2. And if I do if I restart this specific containers, the way you can do that is exit out and then rerun Docker Compose up. And now if I look at the final volumes that I have, I should have a MongoDB data 2 volume as well. MongoDB data, I don't have a MongoDB data 2 volumes because I haven't referenced it most probably. So let me reference it here. Data 2 slash data. And now as you can see, I have the volume. I also have the MongoDB underscore data 2 volume because I've defined it here and I've also used it in one of the containers. And that's it for Docker Compose. At this point, there are a few other things you can do. For example, a lot of times you don't have the image for the backend container. You want ke bhai, this backend container shouldn't use a backend to do image. It should build from the Docker file in the current folder. I repeat, if you want, okay, the backend should build from the Docker file in the current container, which means it should, when Docker Compose starts is when it should rebuild an image from the Docker file in the parent folder. Or, okay, you want Docker Compose to run the Docker build command and you don't want to run it independently, is when you can do a build dot rather than doing an image something, which basically says, okay, you want Docker Compose to build the image as well. You don't want to run the user to run a command to build the image separately. So if you do this and you run Docker Compose up, you will see it actually builds the image first because I said build dot, which means build the Docker file from here, and then everything else remains the same. But rather than giving an image name, I told it to build the image from scratch here. And as you can see, MongoDB connected, which means it was able to build the image. All right, that's it for Docker Compose. At this point, I would urge you to open a few Docker Composes across various projects and try to look at them. They'll generally look very similar. MongoDB will have a bunch of services, will have volumes at the very end. And the best part is all you have to do is run a single command now to start everything in a project locally. You don't need to start MongoDB separately. You don't need to build the image separately. You don't need to run all the 5 run commands. You run a single command, docker-compose up, and it starts everything. That's the benefit of using Docker Compose. The name itself has compose in it, which means run multiple images together. That's all I had for this one. I'll see you guys in the next one. Bye bye.